Hello, Stingray or Dean here. I just wanted to go over something about field of view of a camera and what we might expect to see and what the issues are, because I've seen this is a little bit confusing sometimes. So I just wanted to explain it a little bit. So what I've got here is I've got a lovely model of the Earth with a cloud layer as well. I've got this camera. And there's a few things that I want to have a look at regarding this camera, and the important bits are here. So we've got the sensor size, and we've got the focal length, which gives us a field of view. Now the field of view of the camera at the moment is 65.47 degrees, and if we look here, we're actually looking through that very same camera, so I can alter the field of view. And have, you know, like a really ultra wide shot here. Now this camera is just floating above. It's actually a lot higher than the ISS would be. I think the ISS would probably be about like so. It's only 200 it's in between 250 and 300 miles if I remember correctly. Something about this scene, just really quickly, is I have in fact also got the sun and the moon in correct scales, sizes and distances and everything. So the moon is, if we just have a quick look, all the way over here, and it is in fact 250 or thereabouts thousand miles away. And obviously the sun is 100 times bigger than the Earth, well, over 100 times bigger, and is a lot further away. So with this camera, let's have a look at the geometry of this camera at the moment, because what's amazing about the camera in Maya, which is a 3D software that I'm using, is this end piece of geometry here actually represents the field of view, which is this figure here, the angle of view. So in Maya it's called angle of view, but it's just field of view. So in this animation, what I've got is I pull the camera back, point it down first, and we can see Cuba and Florida and Dominican Republic, and obviously if I get out to here, I've now got quite a wide angle view. Now the distance here at the moment is, let me just work this out. So the distance here is about 2,000 miles high, or maybe 2,500 miles high. And I've got a 12mm focal length, which gives us a 112 degree field of view. Now, let's just evaluate something, and I'm actually going to just take off this cloud layer. Just give me a second, just so that we can see details a little bit more. So if we have a look at this camera, and I'm going to scale it up so that we can see this geometry that represents the field of view. So we can see this field of view, and we can see that it's kind of looking outward, and it's capturing the whole, you know, a circle. Except if we have a look here, we can see that this field of view is not actually capturing Great Britain, Ireland. We're missing Iceland. We're missing a good portion of Greenland. And the Scandinavian region, Sweden is not there. Holland. We can't see Europe. We can't see Spain. But these are in fact on the correct side of the globe that this camera's on. But that's because of the field of view of this camera. So now, in between frame 200 and 400, what I do is I pull the camera back and I alter the field of view to keep the circular size the same. But we can see what happens to it, and the effect is most apparent very early on in this focus pull. Now you get this kind of effect in films when you know, when imagine this is someone's face and you've got a nice little background set here, and oh no, something terrible has just happened, and you get that whoa. In fact, I think it goes the other way, whoa, like that. And all they're doing is they're moving the camera back and changing the focal distance so that the field of view changes and keeps it relatively the same angular size. Except we get this kind of change, and it looks like you're blowing a balloon up. So there you go. So here we can see that we're missing what we should be able to see if we're looking with the camera at about 2,500 miles, maybe 3,000 miles. But when the camera's going back and we get all the way back to here, now this camera is at 500 millimeters, but it's at 200,000 kilometers away, 200,000 miles away from the Earth, from planet Earth. But now I can see Great Britain, all of Greenland, Iceland. I can see most of continental Europe, Spain, big portion of Africa. Now pulling this back down and getting to this point here, I can no longer see them. It doesn't mean that they're not there. Of course they're there. It just means I'm not looking at half of the globe. I'm probably looking at about 35% here. Whereas here, I'm looking more at kind of 48% of the globe. I'm still missing, you know, if we were from the top looking down, I still wouldn't see the equatorial lines or anything that are on the equator. You just wouldn't see them if they were marked on the planet. So yeah, this is basically what I wanted to show. And then there's another, and if we have a look at the camera, it's just out here, just before the moon actually. You can see that it's zoomed in, looking at the planet. But what's cool is if we carry on this little animation, we start pulling all the way back past the moon, and there we go. We've seen this kind of shot before from very, very distant satellites that show the Earth and the moon, but the moon is 250,000 miles away from the Earth. It's just field of view from focal length, which kind of does this effect, and that's what I wanted to show people. Cheers.